Thank you. Before I forget, I want to thank Professor Jean-Jacques Hublin for inviting me. This is really a great honor for me. My French is not good for a presentation like this, so I'm going to do the presentation in English, but I want to say a few words about Professor Coppens in French. Now, I'm going to read it, of course. And I want to warn you not to be fooled by my accent, because my accent is really, really good for French. Yeah. Okay, here we go. J'ai eu la chance d'avoir rencontré Professeur Coppens en personne, même si cela a eu lieu en de trop rares occasions et très brièvement, dans presque tous les cas. Cependant, en tant que paléanthropologique, je connais son travail et ses contributions à la paléanthropologie en général, ainsi que sa place dans l'histoire de la recherche paléanthropologique éthiopienne. La première fois que j'ai rencontré Professeur Coppens, ou plus exactement que je l'ai croisé brièvement, c'était à Addis Abeba dans les années 1980. Au Musée national d'Éthiopie. À cette époque, je n'étais qu'une jeune historienne travaillant au musée. Je l'ai rencontré quelques fois après cela, principalement lors des conférences, mais la plus récente a eu lieu en avril 2019 lors d'un atelier sur l'évolution humaine qu'il avait organisé à l'Académie pontificale des sciences. Je me suis approché de lui pour le saluer et le remercier de m'avoir invité. Et la première chose qu'il m'a dite a été à quel point il était extrêmement heureux de voir de nombreux paléanthropologistes éthiopiens mener des projets en Éthiopie et participer activement à la recherche paléanthropologique. Je crois que c'était ce qu'il avait toujours voulu voir. Malgré ces brèves rencontres avec Professeur Coppens, j'ai toujours admiré ses contributions à la recherche sur les origines humaines et sa place dans l'histoire de la paléanthropologie éthiopienne. C'est ça. Now back to English. So my presentation today is going to be on Lucy's next door neighbors. She was not alone. Now I got to tell you that I'm really happy that my talk was after Fred. My morale is now very high, especially hearing that Australopithecus eurymeda might actually be a valid species. But I'm not going to talk about the diversity that has already been covered by Fred, but I just want to give you a little bit of an introduction about the work that's been done in the Afar Rift. But before that, a few things that I would like to add about Yves Coppens are the following. First, he is, of course, the pioneer of modern paleontological research in Ethiopia, as I mentioned earlier, and you heard that he was one of the key members of the International OMO Research Expedition and also the International Afar Research Expedition. So those are the years when paleontological research in modern sense started in Ethiopia. He was not only a fossil hunter and a discoverer, but also a person who could actually synthesize data, a person who can come up with hypotheses and theories. And two of his most noted hypotheses were Lomo event, which you heard this morning from Jean-Renaud, and also the East Side Story. So whenever I think about the East Side Story, there's something to appreciate about Yves because he is among few scientists who actually accept that he was wrong when the evidence shows up. So he officially accepted that he was wrong on the East Side Story when a team led by Michel found Abel and then Tumai. Right? So he was really honest about that he was wrong, and honestly, you don't see a lot of people like that in our field, unfortunately. So, and also, Lucy, which you've heard a lot about this whole morning, she had a very special place in Yves Coppin's academic career, right? So when you talk about Lucy, which is a 3.2 million year old partial skeleton from Harar, Ethiopia, 40% of her skeleton recovered and found in 1974, Harar became really an attraction for paleoanthropology, and not only the site Harar itself, but it also attracted a lot more researchers to the Afar Rift. And that's why we have so many sites today in the Afar region, from Harar to Dikika, Gona, Middle Awash, Woranzo-Mille, which is the site that I work at. Now, when you think about the concentration of all these sites in the Afar Rift, obviously there has to be an explanation as to why we have all these sites within the East African rift system. So when you look at the image here, what you're seeing here is, as you heard this morning, Africa is ripping apart in different directions, pulling apart from each other in different directions, as you can see by the red arrows here, and it's opening this huge trough within this area, exposing all these ancient deposits that have been buried for more than 6 million years. So Harar has been known since the 1970s, so was Gona, but later on Middle Awash was added, but we've also started identifying new sites like Dikika, which Zerai has led for many years, Ledi Gararu, a more recent site where we now have the earliest evidence of the genus Homo at 2.8 million years ago, and I've been working at Woranzo-Mille since 2004. So when you look at the fossil record that has come out of the Afar Rift, combining the fossils from Woranzo-Mille, from Harar, from Ledi Gararu, and from Middle Awash and Dikika, this is what you see. About 13 of the 20-some-odd species that we have identified in the fossil record have been found in the Afar Rift. And technically, what that means is the discoveries from the Afar Rift cover the entire 6 million years of our evolutionary history. That's really an amazing record from the Afar Rift. But for today, I'm going to concentrate on this window in the mid-Pliocene that Fred talked about, where we have a diversity of hominids. Now, in the 1970s, 1980s, this was not the case. Within that rectangle that you see, there was only one species, Australopithecus afarensis, which is Lucy's species. But now we have a number of species that fall within that time period. So there was definitely some kind of diversity, and that's what we've been arguing among scientists, which one of these species are valid, which ones aren't. And Fred's presentation and all his new results actually show that there was diversity during this time period, right? But if we concentrate on what has come out of Woranzo-Mille, in terms of what evidence is coming out of that site to support diversity, and that Lucy was not alone 3.2, 3.3 million years ago, we need to look at what has come out from Woranzo-Mille in the last almost 17, 18 years, since 2004. That's when we started working at that site. So Woranzo-Mille is located about 35 kilometers north of Harar, and all of these little black polygons that you see are localities that we have identified. And most of what you see here date to between 3.8 and 3.2 million years ago. So we have been able to collect a number of specimens from these localities. So far, we have about 14,500 fossil specimens from about 108 localities. And we do have a good stratigraphic control of where these fossils are coming from, because our geologists have been doing research in this area, collecting samples, dating them radiometrically. So as you can see from the column on the right side, the oldest basalt that we have at 3.82, and it goes all the way up to about 3.2, 3.1 million years ago. So we have good temporal control on the specimens that we're finding. So age range is from 3.8 to 3 million years, and we have thus far identified more than 60 mammalian species. And out of these specimens, 14,500 specimens, we have a little more than 250 specimens that have been identified as hominins, most of which are isolated teeth. But the most important fossil discoveries, how many discoveries that we have from Woranzo-Mille, include what you're seeing here. Now, you've seen the one on the left multiple times in different presentations. That is the cranium of Australopithecus anamensis, 3.8 million years ago that we published in 2019. The second one is Australopithecus deiramida. You've heard about it from Fred and also from mentioned by Emily. We have this partial skeleton from 3.6 million years ago. Now, this is not as well known as Lucy, but this is a partial skeleton that is about 400,000 years older than Lucy. And we have some elements in this partial skeleton that were not fully preserved in Lucy. So it adds a lot of morphological knowledge of Australopithecus afarensis that we didn't have before. And then finally, the Burtele foot, which by any means, no scientist would argue with me that it belongs to Australopithecus afarensis, which is good. That's the most convincing evidence that we have, as Fred also mentioned, to show the presence of multiple hominids during the mid-Pliocene. So for my talk today, since I'm talking about like Lucy's close neighbors, those three highlighted would be the most important. Australopithecus deiramida, Australopithecus afarensis, which is the species that Lucy belongs to, and the Burtele foot, which is BRT VP273. So the question is, who were the neighbors of Lucy? Right? So when we say Lucy now, we're talking about the species Australopithecus afarensis. So what is the evidence from Woranzo-Mille? And I think we have the best evidence for the presence of more than one hominid species during the mid-Pliocene from Woranzo-Mille. This is an indication that Lucy was not alone. And the evidence that has come out of Woranzo-Mille is, as you can see, even though those two sites are very close to each other, 35 kilometers is nothing for an early hominid and even other animals, so they could have walked across like really easily, and so neighbors, right? But even if we look at the hominids within Woranzo-Mille, which is really interesting, what we see is where we have Australopithecus afarensis is also where we have nearby Australopithecus deiramida and the Burtele partial foot. We're talking about 5 kilometers radius for covering the presence of all these hominids, even though the partial skeleton that you see is about 3.6 million years old, slightly older than the others that you're seeing. The distribution of these hominids, even within Woranzo-Mille, clearly shows that there were multiple species living at the same time. So Australopithecus deiramida, which we named in 2015, most of the morphological features that we used to identify that species were mentioned by Fred, but just to give you an idea in terms of what characters we use to diagnose Australopithecus deiramida as different from Australopithecus afarensis, one, its teeth are really small. So that's one diagnostic feature that we mentioned. And morphology of the canine seems to be a little more primitive than what we have for Australopithecus afarensis. We also see that the enamel on the maxilla seems to be thicker than what we have seen on average for Australopithecus afarensis. So the thickness of the enamel kind of falls within the Paranthropus lineage enamel thickness. So for us, that was also something that we could use as a diagnostic feature for this new species. But there was also features from the lower jaw. And this is the position of the ramus root, the one, the bony part that goes up to the head. And we have checked like almost 15 mandibles of Australopithecus afarensis. And none of them seem to have an origin of the ascending ramus anterior to the second molar. So to us, that was really an important trait, or an important feature to use as diagnostic feature for Australopithecus deiramida. So you've heard most of the characters of the maxilla, but there are also characters of the mandible that we thought would distinguish Australopithecus deiramida from Australopithecus afarensis. But of course, deiramida, some of our colleagues don't recognize it as a valid species, and some of them, like on Emily's slide, I saw a big red X on deiramida, which is fine. I'm not blaming you. That's what others have said. But as Fred showed, the maxilla actually is different from what we see in Australopithecus afarensis. So that's why I'm really excited. But still, we have to go back to the field and find more fossils because the sample size is really small right now. We have like 3 or 4 specimens that have been assigned to Australopithecus deiremida. So to convincingly show our colleagues that this is a valid species, we have to go back to the field, find more fossils, and show that this is indeed a different species. But on the other hand, the Burtele foot. This is a foot that did not belong to Australopithecus afarensis. This foot had opposable big toe, and it's a relatively short helical ray, opposable big toe, and the metatarsal phalanx joint had increased range of motion. So those are some of the features that we identified. But then when you look at Australopithecus afarensis foot, it's totally different. It has fully adducted toe, big toe, and the proportions and size of the metatarsals are also different. So this foot cannot be assigned to a species who had a foot like the one that you're seeing in the middle. It rather looks more like Ardipithecus ramidus from 4.4 million years ago. So you heard a little hint from Fred's talk that could it be Ardipithecus, right? But we don't really have the craniodental remains associated with this foot to actually see if it's actually ramidus. Because most of our taxonomic identifications are based on cranial and dental specimens. When you have postcranial like this, it will be very hard to actually assign it to a new species. So that's something that we also have to go back to the site and try to find any associated or at least close by specimens that could be diagnosed either as Australopithecus deiremida or something else. So that foot that you saw, this is just to show you that that foot that you saw, which belongs to non-Australopithecus afarensis species, could not have made those footprints. Those footprints are from Laetoli in Tanzania. They're about 3.6 million years old, and they have fully adducted big toe, and that foot wouldn't be something that would have made those footsteps, those footprints. And one of our systematists who was here chairing the session, when they did the analysis of which taxa are valid versus which aren't, one of the things that they recognized in a high confidence was the difference between Australopithecus afarensis and the Burtele foot. So Burtele foot, no doubt, is not Australopithecus afarensis, which means there are at least two species living at the same time in the Afar region of Ethiopia. So talking about neighbors, talking about living nearby, we have to look at the temporal distribution of all the specimens that we have from Oranzamille and see which ones overlap in time, right? That's why we need like a very refined taxonomic temporal assignment of the specimens that we're finding in the fossil record. So this is one example of the temporal distribution of Australopithecus afarensis that we have from 3.6 all the way to about 3.2 million years ago. We have multiple localities that have yielded remains of Australopithecus afarensis. Then when you look at Australopithecus deiremida, it comes from sediments that are dated to between 3.3 and 3.5 million years ago. You can already see there is an temporal overlap between those two. And you add the Burtele foot to that. It's right in the middle, right? So this is as convincing as you can get it in terms of the presence of multiple hominid species at the same time, and of course overlapping with Lucy's species, Australopithecus afarensis at that time. So when you think about all of this diversity, one question that comes to mind is, how did they manage to coexist in one area at the same time? How were they utilizing the resources? This is really an important question that we have in addition to figuring out like how many species were there. But at least in the case of Oranzamille, we know that there were at least 2 hominid species at that time. So how do we sort this out? How do we know who was doing what? We can only answer that question by systematically integrating data on landscape, habitat, and mammals. And you've heard tectonics so many times. You've heard habitats and mammals. These are all things that we have to really consider if we really want to answer that question, right? So we would like to look at tectonics, the effect of tectonics and volcanism, climate and hydrology. Some of these proxies were mentioned by Jean-Jacques this morning. And there are a lot more proxies that we really need to look at in order to answer the question that I just raised. But we do have some preliminary data, particularly in terms of comparing Harar and Oranjemille, because the question is, why do we have only one species at Harar and multiple species at another locality, which is only 35 kilometers away, Oranjemille, right? So we tried to look at the faunal assemblages that we have from the two sites. And obviously, as you can see, this is at a much higher taxonomic level. This is a family level. But you can already see some differences between Harar and Oranjemille afarensis-bearing localities and where we have the Burtale foot. There are some differences, but this needs to be refined to the lowest taxonomic level so we can do like a meaningful comparison. We also looked at some community structure using modern animals, and what we find out is there's also a difference between what we have from Harar in general and the Australopithecus afarensis-bearing localities in blue from Oranjemille. What this shows you is there was probably more high surface water at Oranjemille than there was at Harar. But interestingly enough, you see here BRT, that's where we have the foot, which indicates that there was probably high surface water availability at BRT than there was either at Harar or the other Australopithecus afarensis-bearing localities, right? But when we look at the faunal abundance analysis, we see that there were a lot more open grassland adapted animals at Burtale than the other sites. So we're getting like contradictory results from two different proxies. So that's why we really need to look at a number of proxies as possible so that we can see what's going on in this environment. So one thing that I want to say here is questions like that cannot really be answered by one scientist. This is something that requires multidisciplinary approach by many participants, and most of the proxies that you see on the paleoenvironmental proxy side, these are things that we need to do. And on the paleontology and paleoanthropology side, the same thing. We have to refine the taxonomy of the fossils that we're finding and so forth. So this is going to be an international multidisciplinary effort to answer the question, why do we have just one hominid species at Harar and so many multiple hominid species at Oranjemille? So having said that, just to summarize my presentation, the fossil evidence from Oranjemille, as you've seen from the fossil record, is probably the most incontrovertible evidence for the presence of more than one hominid species during the Middle Pliocene. Secondly, this is something that I'm really interested in, asking like, why do we have multiple hominid species at Oranjemille and only one at Harar? And this is something that we're going to have to work on systematically with a multidisciplinary team. And third, we think that tectonics and habitats and climate may have a role in this partition, multiple hominid species at Oranjemille and only one at Harar. And I think this is a very plausible hypothesis that international multidisciplinary team is out to test. With that, I would like to thank a number of people, mostly all of the scientists who are involved in this research project, whose contributions have been enormous in terms of all the publications that we have published so far, the AFAR people who have always been helpful, and Jean-Jacques, thank you so much for the French translation, editing the French translation, and financial supports from different sources, Keck Foundation, National Science Foundation, the Cleveland Museum of Natural History, Leakey Foundation, National Geographic Society, Wenner-Gren Foundation, and the Paleoanthropological Scientific Trust of South Africa. Thank you.